What if I told you we could literally touch the echoes of the Big Bang? Not with a time machine, but simply by looking at the oldest stars shining above us. These stars are not just ancient, they are cosmic fossils, carrying within their light the DNA of the universe itself. Some of them were born just a few 100 million years after creation, and they hold clues so shocking that scientists believe they could rewrite everything we thought we knew about the cosmos. Welcome to Starsky Science, where today we unravel the mystery of the oldest stars in the universe and the unbelievable secrets they are hiding. If you're passionate about deep space, mind-bending science, and discoveries that challenge human imagination, then make sure to hit subscribe right now. You won't want to miss what's coming. Now, let's dive in. The first question scientists asked was simple: how old can a star truly be? If the universe itself is estimated at around 13.8 billion years, then the very first stars, called population 3 stars, must have formed almost immediately after the Big Bang. Yet, none of those stars have ever been directly observed. Why? Because they were massive, short-lived, and burned out in violent supernova explosions. What we see today are their descendants, faint survivors scattered across the Milky Way and beyond. In 2014, astronomers made a startling discovery: a star in our galaxy, SMSS J031130.36-670839.3, which appears to be over 13.6 billion years old, almost as old as the universe itself. This star has almost no heavy elements, meaning it was born from nearly pristine hydrogen and helium, untouched by previous generations of stars. It's like a living fossil from the dawn of time, orbiting quietly in the outer halo of the Milky Way. Think about that for a moment. This tiny, dim star has been shining since long before Earth even existed. It has witnessed the birth of galaxies, the collision of cosmic structures, and the rise of our solar system, all while holding within its core the secret recipe of the early universe. NASA scientists often describe these stars as time capsules, and for good reason. By studying their chemical fingerprints, astronomers can tell which elements existed at different moments in cosmic history. For example, stars with more metals, astronomers call every element heavier than helium a metal, must have formed later, after countless supernovae seeded the universe with new elements. But stars like SMSS J031300 are almost pure hydrogen and helium, a clue that they were among the very first to exist. And here's the unbelievable part: recent research suggests that some of these ancient stars might have formed in regions where dark matter played a role in igniting their birth. Imagine that, the invisible, mysterious matter that makes up most of the universe may have been the spark that lit the very first stars. Before we go deeper, let me ask you something. If you had the chance to look through a telescope and see the very first star ever born in the universe, would you want to see it even if it only looked like a tiny faint dot of light? Let me know in the comments. I'd love to hear what fascinates you more, the idea of the first stars, or the possibility that we might never truly see them. Now, the story gets even stranger. Astronomers once discovered a star so old that, mathematically, it seemed to be older than the universe itself, at least according to earlier calculations. The star, known as HD 140283, or more famously, the Methuselah star, was initially estimated to be 14.5 billion years old. That was a cosmic paradox, because how could a star be older than everything? Later refinements adjusted the age closer to 13.7 billion years, but the mystery remains: this star is so ancient, it may have formed right at the dawn of time. For scientists at NASA, the European Space Agency, and observatories worldwide, these discoveries are like breadcrumbs leading us back to cosmic origins. Every time they uncover a new ancient star, they're piecing together the universe's hidden diary, a story of violent births, unimaginable forces, and the slow, quiet endurance of starlight. And this is just the beginning. Because as we'll see in the next part of this documentary, these stars don't just tell us about the past, they might be hiding shocking clues about the ultimate fate of the universe itself. But before we continue, if you haven't yet, don't forget to subscribe to Starsky Science. Your support helps us bring you the deepest, most fascinating stories from the cosmos. When astronomers first began to suspect that some stars in our galaxy were older than anything else we could observe, it felt like they had stumbled upon hidden fossils buried in the night sky. But unlike fossils and rock, these relics of creation aren't sitting still. They're orbiting silently, tucked away in the halo of the Milky Way, so faint that spotting them is like finding a single grain of sand on an endless beach. So, how do scientists actually detect these unimaginably old stars? The secret lies in a technique called stellar spectroscopy. When starlight is broken down into its component colors, its spectrum, it reveals dark lines, fingerprints left by the elements inside that star. A star rich in carbon, iron, or oxygen will show it clearly in its spectrum. But the oldest stars, the ones we're looking for, show almost nothing at all, just hydrogen and helium, the firstborn elements of the cosmos. It's hard to overstate how delicate this work is. Astronomers spend countless nights gathering data from the faintest pinpricks of light, and then they run that data through models to determine chemical composition and age. What they often find is staggering: stars so poor in heavy elements that they must have formed before the universe had time to produce much of anything. One of the best tools in this search has been the European Space Agency's Gaia mission, a space observatory launched in 2013. Gaia's purpose is to chart a three-dimensional map of our galaxy with unprecedented precision. And in doing so, it has uncovered stars with motions and positions that place them in the very outskirts of the Milky Way, the galactic halo, where the oldest stars are most likely to dwell. But Gaia is not working alone. The Hubble Space Telescope and now the James Webb Space Telescope, JWST, are helping to look deeper into cosmic time. JWST, in particular, has shocked scientists by revealing galaxies so old and massive that they challenge our entire timeline of cosmic evolution. If galaxies can form so early, then ancient stars must have played an even more critical role than we imagined. Let's pause for a second and really think about this. These stars are so old that they were here long before Earth, the Sun, or even the Milky Way as we know it. They carry within them the signatures of the Big Bang itself. Imagine peering at one faint star through a telescope and realizing that the light reaching your eye has been traveling for almost the entire history of the universe. That star has survived every cataclysm, every collision, every cosmic upheaval for billions of years. And here's where things get even more mysterious. Some scientists believe that these ancient stars might not just be normal stars at all. They might be what's called dark stars, objects powered not by nuclear fusion, but by dark matter annihilation. This is still speculative, but recent JWST data has hinted at bright objects in the early universe that don't fit neatly into our current understanding. Could it be that dark matter itself once lit up the cosmos? Now, if that's true, it means that the oldest stars we're observing could be whispering to us not only about the beginning of time but also about one of the greatest unsolved mysteries in physics, the nature of dark matter. But let's return to the Milky Way for a moment. Why are most of the ancient stars found in the galactic halo rather than the disk where our sun resides? The answer lies in cosmic violence. Billions of years ago, smaller galaxies collided and merged with the Milky Way. In these collisions, many ancient stars were flung into wide, sweeping orbits around the galaxy, where they remain today, relatively untouched. The halo is like a graveyard, a museum of ancient relics suspended around us, and each star is a survivor from a forgotten age. One such relic is the famous Methuselah star, HD 140283, which I mentioned earlier. Located just 190 light-years away, a close neighbor in astronomical terms, it shines faintly in the constellation Libra. Despite being visible in modest telescopes, its composition and motion reveal its incredible antiquity. When astronomers studied it, they realized it might be older than the universe itself. Although newer calculations adjusted its age slightly, the fact remains, this star is so ancient that it forces us to reconsider the boundaries of cosmology. And that's not the only one. Stars like BD plus 17°3248 and CS 22892-052 have been found to be almost as old, with ages surpassing 13 billion years. Some of these stars contain traces of elements like europium and thorium, radioactive elements that act like cosmic clocks. By measuring how much of these elements remain, scientists can estimate how long the star has existed. And again, the results always point to the same conclusion: these stars are unimaginably old. Now, I want to ask you something to keep this conversation alive. If you had the choice, would you rather see the very first star in the universe, or the very last star, the one that will shine after all others have gone out billions of years from now? Drop your answer in the comments, because I'd love to see which vision of time fascinates you more, the dawn of creation or the twilight of eternity. By the way, if you're enjoying this deep dive into the mysteries of the universe, make sure to subscribe to Starsky Science. We bring you authentic, science-backed explorations of space, blending the voices of NASA discoveries, ESA missions, and independent researchers. Subscribing ensures you'll never miss the next revelation about our cosmic origins. Now let's dig even deeper. One of the ways we know these stars are old comes from studying their metallicity, the amount of heavy elements inside them. Astronomers classify stars into three broad populations. Population 1 stars, like our Sun, are metal-rich and formed recently in cosmic terms. Population 2 stars are metal-poor, older, and often found in globular clusters. Population 3 stars, the very first generation, are thought to have had virtually no metals at all. Here's the catch: no true population 3 star has ever been directly observed. Every star we've studied so far belongs to population 2 or I. But the handful of extremely metal-poor stars discovered in the halo may be as close as we'll ever get to the first generation. Some of these stars show almost no iron at all, which is stunning, because even a single supernova explosion can enrich gas with detectable metals. The fact that these stars lack them means they were born almost directly from the untouched hydrogen and helium created in the Big Bang. Let me give you a real-world example. In 2014, a team using the SkyMapper telescope in Australia found a star with the catchy name SMSSJ031300.36-670839.3. This star had so little iron that it was practically invisible in its spectrum. Its existence confirmed that some stars formed almost immediately after the first supernovae seeded the universe with heavy elements. And that means we are literally seeing the fingerprints of the universe's first chemical experiments. It's discoveries like this that give astronomers goosebumps. Because each star is not just a point of light, it's a data archive, a message from the past, preserved for billions of years and delivered straight to our telescopes. But here's the twist: these stars don't just tell us where we came from. They might also hint at where we're going. The physics of ancient stars can help us refine the rate of cosmic expansion, known as the Hubble constant. And as you might know, right now there's a huge controversy in cosmology because different methods of measuring the expansion rate give different results. Some use the cosmic microwave background, others use supernovae and Cepheid variables. But what if ancient stars themselves can tip the balance and reveal the true age and expansion speed of the universe? Think about that. By studying the oldest stars, we might not only unlock the past, we might be peeking at the ultimate fate of the cosmos. And that, my friends, is why these stars are more than just distant specks of light. They are time machines, paradoxes, and cosmic oracles all in one. So as we move forward in this documentary, remember this: the night sky is not just a view. It's a library. And the oldest stars are the most precious books in that library, books that scientists are still struggling to translate. Stay tuned, because in the next part, we're going to look at something even stranger: how the deaths of the first stars seeded the universe with the very atoms that make up life itself, and why without those ancient titans, we might never have existed at all. When we talk about the oldest stars, it's easy to picture them as small, dim, and quiet, barely burning in the darkness of space. But the truth is far more dramatic. The first generation of stars, the so-called population 3 stars, were cosmic giants. Some were hundreds of times more massive than the Sun, burning with such intensity that they lived only a few million years before collapsing in spectacular deaths. Imagine this: a universe just a few hundred million years old, dark, silent, filled only with clouds of hydrogen and helium. Suddenly, gravity pulls these gases together, and the first stars ignite. They burn hotter and brighter than anything before or since. These are titans, blue, massive, unstable. And almost as quickly as they are born, they die in cataclysmic explosions that shake the infant cosmos. Why does this matter? Because those deaths created everything we are. When a massive star runs out of fuel, its core collapses under gravity. If the star is massive enough, the collapse is so violent that it creates an explosion called a supernova. In those fleeting moments of unimaginable energy, new elements are forged: carbon, oxygen, nitrogen, iron. The building blocks of planets, oceans, trees, and even the DNA inside your body were all born in the heart of dying stars. NASA scientists often say, "We are made of star stuff." But when you trace that statement to its origin, it becomes even more profound. We are made of the ashes of the very first stars. The light from those explosions raced across the cosmos, while the debris spread into space, seeding the next generation of stars. Without those violent deaths, the universe would still be nothing but hydrogen and helium. No Earth. No life. No you. Think about that for a moment. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it once burned inside a star billions of years ago, before being scattered in a cosmic storm and reassembled into living beings. It's a fact so staggering, so poetic, that even hardened scientists often pause in awe. But not every death was the same. Some of these massive stars collapsed directly into black holes, devouring their own cores and leaving behind regions of space where not even light could escape. Others became neutron stars, incredibly dense objects no bigger than a city but heavier than the sun. These exotic remnants are like cosmic laboratories, where physics itself bends to its extremes. The early universe must have been filled with these deaths. A storm of supernovae, black holes, and neutron stars, all lighting up the young cosmos. For astronomers, it's almost impossible to imagine the violence of that age. Yet, without it, galaxies like the Milky Way would never have formed. This raises an important question: if the first stars died so quickly, how do we study them today? The answer lies in their fingerprints. The elements they produced were locked into the next generations of stars. By studying ancient stars in the halo of the Milky Way, astronomers can detect traces of those first supernovae. The chemical signatures tell the story. Some ancient stars contain more carbon, others more magnesium, still others rare heavy elements like uranium. Each pattern is like a clue, revealing the kind of star that must have exploded to create it. This is cosmic detective work on the grandest scale. Scientists are piecing together the history of the universe not from fossils and rock, but from glowing embers of light. Now let me ask you something for the comments. Do you think the universe feels more alive because it had to go through this cycle of creation and destruction, or does it make it feel more terrifying? Share your thoughts. I'd love to know how you see it. And by the way, if you're finding this story as fascinating as I do, remember to subscribe to Starsky Science. We're just scratching the surface of what the oldest stars are hiding. Because as we'll see in the next section, those deaths didn't just create elements. They may have shaped the very structure of galaxies, and possibly even played a role in the origins of life itself. The universe's first supernovae were more than just explosions, they were cosmic architects. The shockwaves from those detonations rippled through clouds of gas, compressing them, sparking new waves of star formation. In this way, the death of one star gave birth to countless others. Creation and destruction weren't opposites, they were partners in building the cosmos. But what about the black holes left behind? For a long time, scientists believed these black holes simply sat in the darkness. But new research suggests they may have grown rapidly, merging together and pulling in surrounding gas to form the seeds of supermassive black holes, the giants we now see at the centers of galaxies. That's right. The supermassive black hole at the heart of the Milky Way, known as Sagittarius A*, may owe its origins to the deaths of those first stars. Without them, our galaxy itself might look completely different. And it doesn't end there. Some ancient neutron stars, spinning rapidly, may have collided in cataclysmic crashes that created gravitational waves, ripples in spacetime that we can detect today. These collisions also produce gold, platinum, and other heavy elements. In other words, the jewelry we wear and the electronics we use are literally born from the collisions of stars billions of years ago. It's humbling, isn't it? Every ring of gold, every piece of silver, every tiny atom of copper in a circuit board, traces its ancestry to cosmic explosions so violent that they warped space itself. But here's the most unbelievable part: without these violent events, life as we know it may never have emerged. Earth formed from a cloud of enriched gas, filled with heavy elements. The carbon that built the complex molecules of life, the oxygen that allowed respiration, the nitrogen that formed proteins, all came from those ancient deaths. So, in a very real sense, the universe had to kill stars before it could make living beings. Life exists because of death. And that paradox is written into every star, every planet, and every one of us. When NASA's James Webb Telescope looks back into the earliest galaxies, it's not just looking for pretty pictures, it's searching for signs of this transformation. Webb's infrared eyes can detect the glow of ancient galaxies where the first stars died, lighting up the universe for the first time. And already, Webb has found galaxies that appear too massive, too evolved, for their age. It's forcing scientists to ask, did those first stars burn even faster, die even more violently, than we thought? Here's a thought experiment: what if somewhere out there, far beyond our galaxy, there still exists a survivor, a true population 3 star that never died, still shining faintly after 13 billion years? It would be the most precious discovery in the history of astronomy. Not just a fossil, but a living witness to the birth of the universe. Do you think we will ever find one? Drop your guess in the comments. I want to know if you believe science will one day catch a glimpse of the very first star still alive today. As we close this segment, remember this: the universe we see, the galaxies, the planets, the very air you breathe, was forged in the fires of ancient stars. Their deaths were not the end, but the beginning of everything that matters. For centuries, humans have looked to the stars to measure time. Farmers once planted crops by the rising of constellations, sailors navigated oceans by the positions of stars, and entire calendars were built on their cycles. But what if I told you that astronomers today are still using stars to measure time, not just years or centuries, but the entire age of the universe? That's right. Some stars are so ancient, so primitive, that they've become the ultimate cosmic clocks. By studying their light, we can measure not only how old they are, but also test the very timeline of the cosmos. And sometimes, what we find doesn't make sense at all. So how do scientists tell how old a star is? Unlike people, stars don't come with birth certificates. Instead, astronomers rely on stellar evolution models. A star's mass, temperature, and brightness determine how long it can live. Smaller stars like red dwarfs can burn for trillions of years, while massive stars burn out in just a few million. But here's the trick: stars also contain trace amounts of radioactive elements, like uranium and thorium. Just as archaeologists use carbon dating to determine the age of fossils, astronomers use radioactive dating of stars. By measuring how much uranium or thorium remains, scientists can estimate how long the star has been around. One of the most famous examples is the star BD plus 17°3248, which contains thorium. When astronomers studied it, they estimated it was nearly 13.8 billion years old, almost exactly the same as the age of the universe itself. That's an extraordinary coincidence. Then came the star that shook astronomy, HD 140283, better known as the Methuselah star. Early calculations suggested it was 14.5 billion years old, older than the universe. Of course, that couldn't be right. But it forced scientists to question everything, from their models of stellar evolution to their measurements of the universe's expansion. Later refinements brought its age closer to 13.7 billion years, but the puzzle remains: how could a star form so close to the beginning of time? This isn't just an academic curiosity. If these stars are truly older than our best estimates, it could mean one of two things: either the universe is older than we think, or our understanding of how stars age is incomplete. And that's where things get even stranger. Some stars appear younger than they should be. In globular clusters, those dense, spherical swarms of ancient stars orbiting galaxies, astronomers often find stars that look suspiciously blue and hot. They call them blue stragglers. These stars should have burned out long ago, but they look fresh, as if they'd been reborn. The leading theory is that they're the result of stellar collisions or mass transfers, where one star siphons material from another, essentially rejuvenating itself. In other words, the universe has stars that cheat time. This duality, some stars that look impossibly old, others that seem suspiciously young, reveals just how tricky it is to measure cosmic time. And yet, stars remain our best tools. By studying their light, we not only trace the history of the cosmos, but we also find cracks in our models that could lead to deeper truths. Now, I want to hear from you. If you could ask an ancient star one question, what would it be? Would you ask what it saw at the dawn of time, or would you ask what it predicts for the end of everything? Let me know in the comments, I'll be reading your answers. And if you're enjoying this exploration of the oldest mysteries in the universe, don't forget to subscribe to Starsky Science. Each new discovery we share here comes straight from the cutting edge of astronomy, so you'll always be among the first to know what secrets the stars are revealing. Because in the next part, we're going to face the big paradox head-on: how can some stars appear older than the universe itself, and what does that mean for our understanding of the Big Bang? Let's face it, the idea that a star could be older than the universe sounds impossible. And yet, some of the best data we have points in that direction. So what's going on? The first possibility is that our measurements of the universe's age are slightly off. Right now, the most widely accepted number is 13.8 billion years, based on measurements of the cosmic microwave background, the faint afterglow of the Big Bang, taken by satellites like WMAP and Planck. These missions mapped tiny fluctuations in the background radiation, which tell us not only the universe's age but also its shape, composition, and rate of expansion. But there's a problem. When astronomers measure the expansion of the universe today using supernovae or Cepheid variable stars, they get a slightly different result than when they measure it using the early universe. This conflict is known as the Hubble tension. Some scientists believe it might point to new physics. Perhaps dark energy is behaving differently than we thought, or maybe there are hidden particles influencing cosmic expansion. If that's the case, then our estimate of 13.8 billion years might need revision. The second possibility is that our stellar aging models are incomplete. Maybe stars like the Methuselah star don't evolve exactly the way we think. Small uncertainties in chemical composition, convection, or nuclear reaction rates could add billions of years to a star's estimated age. If that's true, then stars aren't lying about the universe's age, they're just more complex than we realized. And then there's a third, more radical possibility: maybe both are true. Maybe the universe is slightly older than we think, and our models of stars need tweaking. This wouldn't be the first time astronomy has had to rewrite its textbooks. Think about how many times science has faced paradoxes. Once, people thought the Earth was the center of the universe. Later, astronomers believed the Milky Way was the only galaxy. Each time, new data forced us to expand our perspective. Maybe these ancient stars are about to do the same. In fact, some researchers have proposed bold alternatives. What if time itself doesn't flow the way we assume? What if the Big Bang wasn't the absolute beginning, but just one phase in a larger cosmic cycle? These are speculative ideas, but paradoxes like the impossible stars keep pushing scientists to think beyond the limits of established models. Here's where things get truly fascinating. If some stars really are older than our current universe age, they could be evidence of pre-Big Bang physics, a hint that the cosmos existed in some form before what we call the beginning. It's a controversial idea, but science has always thrived on questions that seem outrageous at first. And here's where I want your opinion. Do you think the Methuselah star is simply a quirk of measurement, or could it really be pointing to something much deeper, something that changes our understanding of time itself? Share your thoughts in the comments. In the next, we'll explore an even bigger mystery, how the oldest stars help scientists predict the future of the cosmos, and why some believe these relics are whispering the universe's final destiny. Have you ever wondered if the stars could be older than the galaxies themselves? Imagine a lonely, ancient star wandering in the vastness of the universe, surviving longer than civilizations, longer than galaxies, and almost as long as time itself. These are the cosmic survivors, and the stories they hold may be the closest humanity has ever come to touching eternity. In the mid-20th century, astronomers made a groundbreaking discovery: not all stars are alike when it comes to age and chemistry. They classified them into Population 1, Population 2, and Population 3 stars. Population 1 stars, like our Sun, are rich in metals and formed relatively late in cosmic history. Population 2 stars are ancient, with extremely low metallicity, suggesting they formed soon after the first stars seeded the universe with heavier elements. And then there are Population 3 stars, the holy grail of astronomy. These were the first stars to ever exist, born from pristine hydrogen and helium, and they remain hypothetical because we've never observed them directly. This classification transformed astronomy into a kind of cosmic archaeology. Instead of digging into the Earth's soil, scientists dig into the light of the oldest stars to reconstruct the history of the cosmos. When astronomers study extremely metal-poor stars, they're essentially looking at time capsules. These stars formed at a time when the universe had not yet been enriched by supernova explosions. They contain only traces of elements like iron, carbon, and oxygen. One example is He 1523-0901, a star discovered in 2007. It is around 13.2 billion years old. Its spectrum showed signatures of uranium and thorium, radioactive elements that astronomers use like natural clocks. Measuring their decay tells us just how ancient the star is. Another fascinating star is SMSS J031300.36-670839.3 in the Milky Way halo. It has such a low iron content that it seems almost untouched by the universe's later chemical evolution. It's like a living fossil of the early cosmos. These stars are like whispers from a time when galaxies were still forming, when the first black holes were emerging, and when cosmic darkness was slowly giving way to light. Our Milky Way has a stellar halo, a roughly spherical cloud of stars surrounding the main disk. Most of these stars are very old, often more than 12 billion years in age. The halo may hold the remnants of smaller galaxies the Milky Way devoured billions of years ago. When our galaxy merged with others, their stars were pulled into orbit around the Milky Way, like ghosts haunting the edges of space. This means some of the oldest stars we observe today might not even be native to the Milky Way. They could be immigrants from long-destroyed galaxies, survivors of cosmic cannibalism. Here's where things get even more unbelievable: the motions of ancient stars in the halo provide indirect clues about dark matter. Dark matter doesn't emit light, but it exerts gravity. By studying how the oldest halo stars move, astronomers can map out the invisible skeleton of the Milky Way. Some studies even suggest that by analyzing ancient star clusters, we may uncover whether dark matter clumps differently on small scales than expected. If true, this could completely revolutionize physics, forcing us to rethink what the universe is made of. Imagine a ball of hundreds of thousands of stars, all packed tightly together, orbiting the galaxy like a satellite. These are globular clusters, and most of them are over 12 billion years old. The famous M13 in Hercules and Omega Centauri are spectacular examples. These clusters contain some of the oldest known stars, shining since the universe was still in its infancy. Globular clusters pose puzzles. Why did they form so early? How did they survive galactic collisions? And why do some of them contain multiple stellar populations, as if different generations of stars were born in the same tight environment? Some scientists even argue that globular clusters could be the leftover cores of dwarf galaxies that the Milky Way consumed long ago. Not all ancient stars are still burning. Many have died and become white dwarfs, the dense, Earth-sized remnants left after stars like the Sun exhaust their fuel. The coolest and faintest white dwarfs are essentially stellar corpses more than 12 billion years old. By measuring their temperature, astronomers estimate their cooling age, which in turn tells us about the age of the Milky Way's disk and halo. In a way, white dwarfs are like the fading embers of the cosmic fire. They silently record how long the universe has been alive. Here's one of the greatest unsolved mysteries: why haven't we found a population 3 star yet? These first-generation stars were likely giants, hundreds of times more massive than the Sun. They lived fast and died young, exploding as supernovae within just a few million years. But astronomers believe that tiny, low-mass population 3 stars could still exist today, hiding somewhere in the halo, too faint to be noticed. Finding just one would be like discovering the Rosetta Stone of the cosmos. It would show us directly what the very first stars were like. The James Webb Space Telescope is already on the hunt, scanning distant galaxies for the fingerprints of these first stars. Some researchers think JWST might finally give us a glimpse of their light. Have you heard of stellar streams? They're like trails of stars stretched across the sky, remnants of galaxies and star clusters torn apart by the Milky Way's gravity. Some of these streams contain stars that are older than our galaxy's disk, meaning they were part of ancient dwarf galaxies long before the Milky Way absorbed them. By mapping these streams, astronomers are literally reconstructing the family tree of the Milky Way. It's like watching a forensic investigation unfold, revealing the galaxy's violent past. Now, here's the part that truly feels unbelievable: some ancient stars may actually predate the Milky Way itself. That means we are looking at objects that were shining before our galaxy even existed. Think about that for a second. Before the spiral arms of the Milky Way wound themselves into shape, before the Sun, before Earth, before any life, these stars were already out there, burning steadily, carrying memories of a cosmos we can barely imagine. Now I'd love to ask you something. If you could look at the light from a star that's older than our galaxy, what would you want it to reveal? Would you want to know about the first galaxies, the first black holes, or maybe something about the mysterious dark matter that binds everything together? Backhand index pointing right. Share your thoughts in the comments below. I'll be reading them. The hunt for the universe's oldest stars is more than astronomy, it's an attempt to touch the very origins of existence. Each discovery reshapes our understanding of where we came from and what the universe truly is. If you're fascinated by these timeless survivors of the cosmos, don't forget to subscribe to Starsky Science, hit the like button, and share this video with friends who love exploring the mysteries of space. Because in the end, the universe is not just out there in the stars, it's a story we are all part of. What if I told you that somewhere, hidden in the vastness of our galaxy, there are stars so old that they witnessed the birth of the first galaxies, stars that may contain elements forged in the very heartbeat of the Big Bang itself? These are not ordinary suns. They are cosmic fossils, time capsules carrying the chemistry of creation. And today, on Starsky Science, we're diving deep into the story of these ancient suns, their unbelievable secrets, the mysteries they hold, and why they might rewrite everything we think we know about the cosmos. Astronomers have a way of categorizing stars by something they call metallicity. In astronomy, metals don't just mean iron or gold, but every element heavier than helium. The first stars, those born just after the Big Bang, contained almost no metals. They were forged almost entirely from hydrogen and helium. And when astronomers search for the oldest stars, what they really look for are those with extremely low metallicity. One such star is He 1523-0901, located about 7,500 light-years away in the constellation Libra. This star is a record-breaker, estimated to be around 13.2 billion years old. That means it formed only a few 100 million years after the universe itself was born. When scientists measure the tiny amounts of thorium and uranium in its spectrum, they find a chemical clock ticking since the dawn of time. This is one of the oldest known stars still burning today, and it is practically a relic of cosmic antiquity. But even older mysteries exist. Take the famous Methuselah star, officially named HD 140283. This star is located just 190 light-years away, a close neighbor by galactic standards. For decades, astronomers puzzled over its age. Measurements suggested it was 14.5 billion years old. But there's a problem with that number. The universe itself is only about 13.8 billion years old. How can a star be older than the universe? The answer lies in measurement errors and refinements in our models. Eventually, scientists revised the Methuselah star's age to about 13.2 billion years. Still, the puzzle left behind an intriguing question. Are there cosmic processes we don't fully understand that might allow a star to appear older than everything else around it? It's like finding an artifact in archaeology that predates the Earth itself, utterly baffling, and potentially groundbreaking. One of the most exciting things about studying old stars is their chemistry. These ancient suns are living laboratories, carrying within them the fingerprints of the earliest supernova explosions. When a massive star died in the infant universe, it scattered elements across space. Some of those elements ended up inside the next generation of stars. When astronomers peer into the spectrum of a metal-poor star, they are effectively reading a chemical code, a message written billions of years ago. For instance, some old stars show strange ratios of carbon to iron, or peculiar enrichments in elements like europium or strontium. These chemical anomalies suggest that the very first stars may have exploded in ways we don't entirely understand, possibly through exotic hypernovae or parent stability supernovae that released unusual blends of elements. The holy grail of stellar archaeology is finding what astronomers call population 3 stars. These would be the very first stars ever formed in the universe, pure hydrogen and helium, no metals whatsoever. So far, none have been found. The oldest stars we see today are usually population 2, still very old, but already contaminated with the products of earlier star deaths. Why can't we find population 3 stars? The reason is simple but dramatic. The first stars were massive, hundreds of times heavier than our Sun. They lived fast and died young, burning out within just a few million years. If any tiny population 3 stars were ever born, they might still be out there, hidden in the Milky Way halo or dwarf galaxies. Spotting one would be like finding the Rosetta Stone of cosmology, a direct glimpse into the birth of starlight itself. But age isn't the only mystery. Some of the universe's oldest stars seem to move in unusual orbits around the Milky Way. Instead of gliding gracefully within the galactic disk, they wander through the halo, vast, spherical regions surrounding the galaxy. Their paths suggest that they might not have been born here at all. In fact, some of these stars may have formed in ancient dwarf galaxies that were later devoured by the Milky Way. When our galaxy grew by swallowing smaller neighbors, it absorbed not only their gas and dust but also their ancient stars. That means some of the old stars we see today might actually be immigrants, visitors from long-gone galaxies that lived and died billions of years ago. And this raises a profound question. Could the Milky Way itself be a mosaic of ancient galactic fragments, stitched together over cosmic time? If so, every old star we study is more than a time capsule. It is a refugee from another cosmic homeland. One of the most ingenious methods astronomers use to measure stellar ages involves radioactive decay. Just as archaeologists use carbon dating to estimate the age of ancient bones, astrophysicists use isotopes like uranium-238 and thorium-232. These atoms decay over billions of years, acting as natural cosmic clocks. When astronomers detect the faint signatures of these elements in ancient stars, they can compare their ratios to estimate when the star formed. This technique has confirmed that many of the oldest stars really are nearly as old as the universe itself. It's staggering to think that the atoms inside these stars have been ticking away since the first moments after creation, silently recording the passage of cosmic time. One of the best hunting grounds for ancient stars is the galactic halo. Unlike the bright, star-rich disk where we live, the halo is sparse, filled with ancient globular clusters and lonely stars drifting in orbits far above and below the Milky Way. These clusters are among the oldest structures in the galaxy, with ages of 12 to 13 billion years. Globular clusters like M92 or Omega Centauri are stellar fossils. Each cluster is a swarm of hundreds of thousands of stars, all born together in the early universe. By studying them, astronomers get a window into conditions that prevailed shortly after the Big Bang. Some clusters even show multiple generations of stars, suggesting that they may have once been the cores of dwarf galaxies consumed by the Milky Way. Why should we care about these ancient suns? Because they are our most direct link to the cosmic dawn. They tell us how the first elements were forged, how galaxies assembled, and perhaps even whether dark matter influenced the birth of stars. By piecing together the story of the oldest stars, scientists can refine our understanding of the early universe in ways no telescope looking at distant galaxies alone could achieve. And here's where you, the viewer, can join in. What do you think is more exciting, finding a true population 3-star untouched by metals, or discovering a star so paradoxical that it challenges our very understanding of physics? Share your thoughts in the comments below. I'd love to hear your ideas. Have you ever considered that some of the stars shining above us tonight might have been born long before Earth even existed? Imagine that for a moment. These cosmic elders, still burning after more than 13 billion years, are like living fossils of the universe. They don't just emit light, they preserve whispers of creation itself. And within those whispers lies something scientists are only beginning to decode, clues that might change how we think about our own place in the cosmos. You're watching Starsky Science, and if you're fascinated by mysteries hidden in starlight, make sure to hit subscribe. Because the deeper we go, the stranger the universe becomes. The most ancient stars, called population 2 stars, carry almost no heavy elements. In astronomy, metals means anything heavier than helium, so when a star has almost no metals, it means it was formed close to the Big Bang. These stars are so chemically primitive that they act as time capsules. They allow us to reconstruct the environment of the newborn universe. What's astonishing is that some of these stars have metallicities less than 1/1,000,000th that of our Sun. Think about that. Our Sun is relatively young at 4.6 billion years old, and in its belly are carbon, oxygen, silicon, iron, and dozens of other elements. But the ancient stars we're talking about? They're almost pure hydrogen and helium, sprinkled with the faintest trace of lithium. Why is this important? Because it tells us something profound. They were forged before enough supernovae could enrich the cosmos with heavy elements. That means they were born in a cosmic environment still untouched, almost like fresh snow after the first storm of creation. Now here's where it gets strange. Some of these stars, while nearly metal-free, contain odd chemical fingerprints, tiny enrichments of elements like carbon or barium. Where did those come from? Astronomers suggest these stars might have been polluted by a single, nearby supernova, one of the very first explosions after the Big Bang. Imagine that, a star born from the ashes of just one ancestor, carrying its chemical DNA forever. That means by studying these fragile signatures, we're essentially reading the family tree of the universe. But here's a question for you. If you had the chance to hold the light of one of these stars in your hand, knowing it carried the memory of the very first supernovae, what would you feel? Share your thoughts in the comments. I want to hear how you describe touching the oldest evidence of cosmic ancestry. Perhaps the most famous ancient star is HD 140283, also nicknamed the Methuselah star. Its estimated age is 14.27 billion years. Yes, you heard that right. That's older than the currently accepted age of the universe itself, which is 13.8 billion years. Now of course, astronomers know this is a measurement uncertainty. Still, the fact that it even comes close is shocking. It means this star was among the very first objects born after the Big Bang. It has been shining for nearly the entire cosmic history, watching silently as galaxies assembled, as stars came and died, as planets formed, and as life eventually arose on a small blue world orbiting a modest yellow sun. The Methuselah star reminds us of something humbling. The universe's timeline is not just theoretical. It's written, literally, in the light of these stellar elders. When we say looking into space is looking into the past, it's not just a poetic phrase. It's scientifically accurate. The photons emitted by these old stars left them billions of years ago, traveling across expanding space until they finally reach our telescopes. That means observing one of these stars is like peeking into a living time machine. But here's the unbelievable part, the light from these stars also encodes temperature, chemical fingerprints, and even motion. With powerful spectrographs, astronomers can decode what elements existed billions of years ago, and how they were distributed. In other words, the stars are not just glowing, they are speaking. The trick is learning how to listen. Now, here's where things get really interesting. Some scientists believe that the formation of these ancient stars might have been influenced by dark matter. Dark matter doesn't interact with light, but it does exert gravity. In the very early universe, clouds of gas couldn't clump together unless something was pulling on them. And dark matter, forming vast invisible halos, may have provided that gravitational scaffolding. Without it, stars might not have formed as quickly. There's even a radical theory that the very first stars could have been dark stars, giant objects powered not by nuclear fusion, but by the annihilation of dark matter particles in their cores. Imagine stars glowing not from hydrogen, but from invisible matter colliding in a way we still don't fully understand. If that's true, some of the oldest stars in the universe weren't like anything we see today. They were truly alien. You may wonder, why do astronomers care so much about these old, faint stars? The answer is that they are the foundation stones of galaxies. The Milky Way is not one smooth system. It's a patchwork quilt, assembled by billions of years of mergers with smaller galaxies. The oldest stars act as tracers, showing us where these ancient fragments were stitched together. When astronomers map their locations, they discover streams and clusters, fossilized remains of galaxies swallowed by the Milky Way billions of years ago. So when we study these stars, we're not just learning about individual points of light, we're reconstructing the Milky Way's ancestry. One mystery that keeps scientists awake at night is how some of these fragile, ancient stars have survived. Stars more massive than our sun burn out quickly, ending in supernovae. But smaller stars, especially those less than one solar mass, can live for trillions of years. That means many of the oldest stars are still alive today, quietly glowing, having seen nearly everything the universe has done since the beginning. Some of them might outlive the universe as we know it, still burning long after galaxies fade and black holes dominate the cosmic landscape. There's a type of star astronomers have dreamed of finding but never have, population 3 stars. These would be the very first stars, made entirely of hydrogen, helium, and trace lithium. They should have been huge, unstable, and incredibly bright. But so far, none have been confirmed. They may all have burned out long ago. Still, astronomers keep searching. Because if we could find even one, it would be like finding the original Rosetta Stone of the universe, direct evidence of the very first lights ever kindled in cosmic darkness. What if the very first stars of the cosmos were not only different from the stars we see today, but so massive, so unstable, and so alien in nature that they may have birthed the conditions for life itself? Imagine giant furnaces of pure hydrogen, burning with an intensity we can hardly fathom, collapsing and exploding in ways that no star in the modern universe can replicate. These were the stars of the cosmic dawn, and their fingerprints may still exist, written faintly into the light we see from the farthest reaches of space. This is Starsky Science, and before we uncover the wild truths hidden in these ancient suns, make sure you subscribe to the channel for more deep dives into the biggest mysteries of the universe. You don't want to miss what's coming next. Astronomers call them population 3 stars, the first generation of stars to ever shine in the universe. Unlike our sun, which is full of heavier elements like carbon, oxygen, and iron, these stars were made almost entirely of hydrogen and helium, the raw material forged in the Big Bang itself. Now here's the astonishing part. Computer simulations suggest these stars may have been hundreds of times more massive than the sun. Imagine a single star so large, it could swallow thousands of Earth's whole, burning hot enough to create entirely new elements for the very first time. The existence of these stars is more than theory. Their impact is written into the cosmic fabric. Every heavier atom in your body, the carbon in your cells, the calcium in your bones, the iron in your blood, was once born inside these ancient giants. Without them, life as we know it simply could not exist. And yet, none of these original stars are left. They lived fast, died young, and disappeared. But they left behind secrets that scientists are still desperately trying to uncover. Here's where things get fascinating. If these stars exploded in titanic supernovae billions of years ago, their chemical byproducts should have been scattered across the cosmos. Astronomers have discovered ancient, ultrametal-poor stars, stars that formed in the early universe and carry only tiny traces of heavy elements. These stars act like fossils, preserving the chemical fingerprints of those first explosions. By studying the ratios of elements like magnesium, carbon, and iron inside these ancient stars, researchers are able to piece together the story of what population 3 stars must have been like. And the evidence points towards something extraordinary. Some of these first stars may have exploded with forces far greater than even the most violent supernovae we know today. But not all of them exploded. Some of the most massive first stars collapsed directly into black holes, objects so dense that not even light can escape their gravity. And here's where it gets unbelievable. Scientists think these primordial black holes may have acted as seeds for the supermassive black holes we see at the centers of galaxies today. Imagine a black hole forming just a few 100 million years after the Big Bang, and then, over billions of years, growing into the monstrous giants that now sit in the hearts of galaxies, including our own Milky Way. This means that the very first stars may still be influencing the structure of the universe right now, billions of years later. Here's the challenge: none of these first stars exist anymore. So how do we study them? Enter the James Webb Space Telescope, JWST. Its infrared vision allows astronomers to look back to the earliest moments after the Big Bang. Already, JWST has found galaxies that seem impossibly bright and massive for their age, hinting that giant stars may have played a role in creating them. Some scientists even speculate that JWST might directly detect light signatures from the very first generation of stars, if they burned hot enough and for long enough to leave traces in the deep cosmic background. If that happens, it would be like opening a window straight into the dawn of creation. But the universe, as always, keeps secrets close. Did population 3 stars form alone, as solitary giants, or in clusters? Did they trigger the creation of galaxies, or were they shaped by them? And perhaps the biggest question, could the byproducts of their explosions have created the very building blocks of life? Some astrophysicists argue that carbon, nitrogen, and oxygen, the essential ingredients for organic chemistry, may not have existed at all before the first stars created them. That means, in a sense, we are literally the children of those long-dead stars. Before we continue unraveling more about how these ancient stars shaped the universe, don't forget to subscribe to Starsky Science. Every week we uncover the mysteries of space with authentic science, real discoveries, and deep explanations. Hit the subscribe button now, and join our growing community of explorers. Now here's where things take a mind-bending turn. Some scientists believe that the first stars weren't powered by nuclear fusion at all, at least not in their earliest stages. Instead, they propose the idea of dark stars. According to this theory, pockets of dark matter in the early universe may have clumped together so densely that when the first stars formed, they were partially powered by the annihilation of dark matter particles. These wouldn't have been ordinary stars. They would have been larger, cooler, and much stranger, glowing faintly while feeding off the invisible stuff that makes up most of the universe. If this theory is true, then the first stars weren't just the forges of matter, they were laboratories for physics we still don't fully understand. The oldest stars in the universe may be gone, but they left echoes that shape everything we are and everything we see. From the black holes at the centers of galaxies to the atoms in your body, their story is our story. But we've only scratched the surface. In the next part, we'll explore how astronomers are hunting for direct evidence of these first stars, and the astonishing new theories that suggest some of them may still be out there, hiding in ways we never expected. What if the universe is whispering to us through the faint light of its oldest stars? What if, hidden in their dim glow, are answers not just about the birth of galaxies, but about the ultimate fate of everything we know? After exploring ancient star remnants, metal-poor giants, stellar fossils, cosmic chemistry, and the possibility of alien fingerprints etched in starlight, we come to the final reflection: what these stars truly represent for humanity. The oldest stars are not just celestial bodies, they are timekeepers, messengers, and cosmic storytellers. Every photon of their light traveled billions of years, dodging cosmic dust, colliding with magnetic fields, and stretching with the expansion of space before reaching our telescopes. To look at them is to look back almost to the dawn of time itself. That alone is a miracle. Scientists often say, we are made of star stuff. But perhaps more profound is this, we are made of the oldest star stuff. The iron in your blood, the calcium in your bones, the oxygen you breathe, much of it was forged in the earliest stellar explosions. Every heartbeat you feel is literally powered by ancient starlight repurposed into life. And yet, the true unbelievable secret these stars may hold goes beyond the physical. They remind us of cosmic continuity. Stars are born, they live, they die, and from their ashes, new stars and planets rise. That same cycle mirrors our own human existence, birth, growth, death, and renewal. By studying the stars, we are, in some way, studying ourselves. So here's where I want to pause and ask you, the viewer, do you believe the universe will ever reveal its ultimate secret? Or are there truths so vast, so ancient, that they are destined to remain hidden forever? Share your thoughts in the comments. I'm curious to know how you see our place in this cosmic story. From every discovery about these ancient suns, one truth emerges: the universe is far stranger, older, and more mysterious than we once believed. Whether it's stars that appear older than the universe itself, or chemical fingerprints suggesting unknown cosmic events, the lesson is the same: we don't know everything yet. And that is the beauty of science. The stars do not give us all the answers at once. Instead, they challenge us with riddles, leading us deeper into wonder. They are not just passive lights in the sky, but active participants in the greatest mystery of existence. Think about it, you and I are living at a time when we can build telescopes that peer across billions of light years, capturing the glow of stars that burned before Earth even existed. Future generations may look back at us as the first humans to truly begin unlocking the cosmic past. The question is, what will we do with this gift of knowledge? Will we continue pushing the boundaries of exploration? Will we protect our fragile planet, the only cradle of life we know, while reaching for the stars? Or will we let the light of knowledge dim? The oldest stars in the universe are not hiding their secrets out of malice, they are waiting for us to be ready to understand them. Each new discovery brings us closer, not just to knowing the cosmos, but to knowing ourselves. So the next time you look up at the night sky, remember this: the faintest star you see might be a survivor from the first generation of cosmic creation, a witness to 13 billion years of history, a silent guardian of truths that could one day redefine our existence. And maybe, just maybe, the unbelievable secret hidden within them is that we, too, are destined to become a part of that eternal cycle. Stars watching stars. Thank you for watching this documentary from Starsky Science. If you enjoyed exploring the mysteries of the universe's oldest stars, make sure to subscribe to Starsky Science, hit the like button, and share this video with fellow space lovers. Because the universe still has countless stories to tell, and together, we'll uncover them one by one.